Hello, students. We will be discussing part 2 of chapter 2 today. We will continue talking about basic elements of C++. Again, this is a basic fundamental chapter of programming using C++. And it's a very important chapter. Once again, feel free to go over the lectures as many times as you want and as you can in order to understand what is going on in the chapter. Please feel free to read the chapter. Okay, the electronic book is in MindTap on the right hand side corner. You'll see a book icon. Click on it, and you can read. I have also assigned a reading assignment in MindTap, so you click on the read assignment and go over the material there. I have placed a deadline on all these things, on all the activities inside MindTap and Canvas. So make sure you do each and every activity because they all count towards your grade. So again, in this part, we will begin talking about arithmetic operators, order precedence, and expressions. As we all know, in arithmetic, we have addition, subtraction, multiplication, and division, and modulus. For a couple of you that don't know what modulus is, it's basically a remainder. The answer is a remainder. So if you take a mod between two numbers, the remainder is the answer, right? So a mod of 5 and 2 will be 1. Okay. These arithmetic operators can be used with integers, floating points, okay, and other data types. Modulus, on the other hand, can only be used with integer data types. They're not applicable to floating points and double. All right. So in C++, you have you have arithmetic expressions that contains operands and operators. Okay. So you have order of precedence. All operations inside the parentheses is evaluated first. Okay. And then multiplication, division, and mod are at the same level of precedence and are evaluated next. And addition and subtraction, they both have the same level of precedence and are evaluated last. So when operators are on the same level, then the operations are performed from left to right. Okay. In this expression right here that is shown, 3 times 7 minus 6 plus 2 times 5 divided by 4 plus 6 means that 3 times 7 is evaluated first, and then 6 is subtracted from that, right? And then you have the answer there. And then 2 times 5 is evaluated first, right? That's inner parentheses. And then divided by 4, that is another result. And then the end is 6. So the first result plus the second result and plus the 6. That would be the order of operation in C++. And that's the case in all arithmetic, okay, not just in C++. All right. So in expressions that contain integers only, then the result is integers. An expression that contains floating points or double, the end result is floating point or double, right? But you can also have mixed expressions, right? Mixed expressions might contain an integer and a double or a floating point. So then what's going to happen? What is the result of that, right? How the evaluation will take place in mixed expressions, right? So if an operator has both types of operands, then these are the rules. Okay, integer is changed to floating point. Then the operator is evaluated. The result is the floating point, right? So if you have an integer and a floating point, then integer is changed to floating point. Then the operation is performed, and the result is a floating point. So in other words, you need to know this. Don't expect if you use an integer and a floating point, the answer to be an integer. It's not. It's going to be a floating point. Okay, you think of floating point as a more powerful entity that kind of overpowers the integers and forces the integer to convert to its format. Okay, so that is when you convert that integer to a floating point. That's called conversion. In this case, it's a coercion where the integer is automatically converted to a floating point. And that is called implicit type coercion, where it is automatically changed to a floating point. Okay, but you yourself inside your program, you can do typecasting. You can change from one type to another. You can convert from integer to a floating point, right? So what do you use? Static cast and convert to a particular data type. Of course, you're going to write an expression. I will show you a few examples in the next slide. Here it is. For example, the first one shows the first expression here. Okay, the first expression here shows what's going on right here. Right here, you will see that we're doing static cast to an integer, and we're providing a floating point there, and it evaluates to an integer, right? Again, if you take an integer and typecast to a double, then it will evaluate to a double. So you take 25 and convert it to a double, then the result will be 25.0. Okay, and so on and so forth. You can go over these examples, but you get the point now. You understand what's going on in here, how the typecasting takes place. Okay, these are very valuable. Do not think that this skill is not going to be used. It will be used, right? You are going to typecast in your programs, especially when the input is coming in one format and you have to change it to a different format in order to process that information, right? Process the data. So let's go ahead and move on to string type. What is string type? The string type is contains characters. It's a sequence of characters, a series of characters, right? A string is a sequence of 0 or more characters enclosed in double quotation marks. So here, a string is a sequence of 0 or more. You can have no characters in there, just a double quotation. Null. It's called null or empty. So but you have to provide double quotation marks. Okay, to a string. A null or empty string is a string with no characters. So when you do this and don't put anything in there, then that is an empty string. Each character has a relative position in the string, and it starts with 0. Okay, so position value. So if you have A, B, and C, right? Let me just go ahead and let me erase this right there. Okay, so if you have A space B C space, right? So then this value, right, the place value is 0, 1, B is at 2, C is at 3, and the space again is 4. Okay, but so these are place values. But so what is the length of this string? The length of the string is 5. Okay, so the length of the string is 5. So it's explained here. The length of the string is the number of characters in it, right? So space is considered a character also. So In here, if you count the number of strings, number of characters, you have 3, 4, 5, 6, 7 here, and the space is 8, 9, 10, 11, 12, 13, right? So there are 13 characters in this string. So the length of the string is 13. All right. So I don't want you to think that there are 12 characters in here. Don't forget the space. Okay, space counts as a character. All right. So data must be loaded into memory before it can be manipulated. So obviously, when you enter data, where does it go? It goes into memory. And what part of memory does it go into? Whichever memory part that you have reserved for it. So how do you reserve for memory for your data? By using variables, a simple thing. When you declare a variable, you're pretty much telling the computer, hey, I want this much memory, 4 bytes of memory reserved for the data that will be coming into this variable, a kind of a container. So yeah, you cannot just simply put information wherever you want. It has to go into memory, and it has to go into the memory at a certain address location. Named constant, this is another type, but it is not really a type of data, but it's considered a modifier for your type. So let me explain what it means. A lot of books and places and instructors say that constant is a data type. I don't believe so, because if in a minute you will find out what I mean by that. So let's look at the syntax, right? Syntax: constant, data type, and identifier. And this entire thing is an expression, right? And we provide a value, okay? And all statements end with a semicolon. Okay. First up, in C++, constant is a reserved word. C-O-N-S-T. It's a reserved word. That means you cannot use it in your, you cannot name your variables C-O-N-S-T. That's not a good practice. So in C++, const is a reserved word. Let's look at the example. Const double conversion equal to 2.54. Now, this is the data type, right? Double. This is the variable, right? And this is the value that goes into the variable. So this is the value that goes into a variable. And this variable is of the type double, right? This whole thing is a constant. You get me? That means once you declare a constant, you cannot change the value. The conversion value now, the conversion constant, which is of the type double, has 2.54 in it. You can just add 1 to it. You understand? Because you have declared it as a constant. All right. So this is what I said. The data type is already given. It's a double, right? And this is a modifier for that data type, saying that, hey, you know what? This data type, this variable, and this value is a constant. That's what it means. Okay. So now let's look at variable. What is a variable? A variable is a memory location whose content may change during execution. That is a variable, right? And it's not a constant. It's a variable. It's opposite of constant. Look at the syntax. The syntax. You declare a data type, and you identifier. You identify. You set your identifier, and identifiers can be separated by comma, and you can have as many identifiers as you want, and it ends with semicolon. The statement ends with semicolon. So let's look at the examples here. Double amount due. See the camel case right there, right? That's amount and due with a capital D. That's called camel case. Integer counter, straightforward, no problem. Character CH, but here two two variables are declared on the same line, on the same statement. Okay, string name. So what are the different ways to place data into a variable? You can use the C++'s assignment statement, or you can read it off the user's input, right, from the keyboard. All right. There's other ways to read information into your program through files and storage devices and stuff like that. But for now, we will limit our discussion to either assign the values inside your program, right? Or let the user supply the values to the variables. Okay, so this is an assignment. This is assignment statement. I mean, this is the assignment operator. It's not a it doesn't mean that variable is equal to expression. No, it means take expression and put it into the variable container, right? So expression is evaluated, and then the value is put into the variable, right? The variable is set to be initialized the first time a value is placed into it. In C++, equal to is called the assignment operator. Okay, I just explained that to you. So let's look at the example. Suppose you have the following variable declarations, right? Integer number 1, number 2, double sale, character first, and a string str. Now let's look at the assignment statements. So you can put 4 into number 1, and then you have an expression here that needs to be evaluated and then placed into the variable number 2. Okay, then same thing, you have sale expression that needs to be evaluated and then placed into the variable sale, and so on and so forth. Okay, you need to declare a variable of the appropriate data type. You know, C++ is very particular about that. If you don't declare a variable and its data type, then it's going to give you an error. I can guarantee that. So don't do that. Declare a variable and then assign values to the variable. Use that variable in your program. Okay. Otherwise, you're going to get an error. So not all type of variables are initialized automatically. Variables can be initialized when declared. All right, so you can say integer first equal to 13. We've been seeing that, and second equal to 10. What it means is that you're declaring the variable and assigning the value right here, right there and then. Okay, from inside the program. So these are the examples of that. But you can also get a variable from an input device such as a keyboard by using the cin. We can use the cin. I'll tell you what that cin is. Okay, so cin, greater than symbol, variable, greater than symbol, variable, and so on and so forth. And the end of the statement is a semicolon, right? Okay, so what is this called? This is called an input read statement because it has cin, right? Cin as an input read statement, or input read statement contains cin. And the stream extraction operator is this. Okay, so you can abbreviate it SEO, or you can say cin. I prefer cin because it's a lot easier to say. In your vocabulary, if you use cin, people know what it means. It's an input read statement. It's going to have greater than symbol, right? Two greater than symbols. So for example here, cin miles. But you have to, let's say you have already declared miles as a double, right? Double variable, and then now you can get cin and cin miles. which means now the user is going to enter something into the program, and that will be stored in miles. Okay, so that's what it means. You can have more than one variable in a single cin. You can have cin, okay, feet and inches. All right. So then two values are coming from the keyboard, right? So if you have declared feet and inches as integers, then you're going to get two values from the keyboard separated by a space, and then you're going to put first value in feet and the second value in inches. So as a programmer, you have to let the users know, please enter two numbers, integers, separated by a space, and that way the program works perfectly. Okay, so for example here, you have declaring two integers in your program, feet and inches, and the two inputs are coming in 23 space 7, and 23 goes into feet, 7 goes into inches. All right. We are here at the increment and decrement operators. Increment operators means increasing the value of a variable by 1. Okay. Decrement operator means decreasing the value of the variable by 1. So there are two ways to write this: pre-increment and post-increment. Pre-increment, you put a double plus at the beginning, and post-increment, you put double plus after. So what happens is that first here in the pre-increment, right, the value is increased by 1 and then sent, okay, then returned. In post-increment, the value, the current value of the variable is returned, and then it's incremented by 1. Okay, that's a difference, right? And when you the little nuance in difference you will know when you sit down to write programs, okay, of different kinds, which will require one or the other. Okay, right now, most people, most programmers or beginning programmers, they tend to use this, okay, post increment. All right, which is the natural one to use, in my opinion. But there might be situations where you're going to have to first increment and then return it. I'm not going to go into that, but into the detail of it. But when you are working with loops, for example, for loops, that's where you're going to make that decision to do either pre-increment or post-increment. All right. While loops and for loops is where you're going to be using the increment operators or decrement operators. All right. So there is a difference between the two. Let's look at the syntax of cout. We looked at syntax of cin. Now let's look at the syntax of cout. Cout is the output, as you guessed it. So cout, you have an expression or the manipulator, right? And you have another expression manipulator. It's separated by the symbol. Okay, and then the statement ends with a semicolon. Okay, this is called an output statement. Remember, in the previous discussion, we saw that this was called an input statement or read statement, right? So this is an output statement. Stream insertion operator is this right here, right? So for cout, and the expression evaluated and its value is printed at the current cursor position on the screen. That becomes important because once you write that and run this expression, whatever you want to push to the screen, right, and wherever that cursor is, that's where it gets printed, right? So that is important to note, and we'll see in a minute, when we go to in next couple of slides, when we look at end line and new line characters and stuff like that. Okay, so these are the examples of cout. It's in your textbook, and here you can see end line, right? So when you put end line in there, and L, that means that you after printing this, you want the cursor to go to the next line. Why is that important? Well, it is important because when you print something on the screen, the cursor is at the end of that line, of the cout line, right? If you don't put the end line in there. And when the user types, they're like, where do I type my input? Right? So next, after cout, you have a cin statement, let's say, and then the cursor is at the end of cout, and user is confused. And they're trying to hit the enter key. When they hit the enter key, guess what? Null values go in because that goes into your cin. It's confusing situation. So what you need to do is that you need to provide that end line so that the cursor goes to the next line, and now the user says, okay, maybe I need to enter now, right? And avoid hitting the enter key. Okay. So the new line, there are several characters called escape sequences. One of the popular escape sequence is a new line escape sequence. So that allows us to create a new line when you're using cout. So here are the examples. If you say cout hello there and cout my name is James, then the output is hello there, my name is James. But if you put a new line escape sequence in there, then the output is in two lines. Okay, you got that. That's easy. These are some of the escape sequences: new line, tab, backspace, return, backslash, okay, single quote, and double quote. Okay, so you have backslashes, and then you have the abbreviated escape sequences. Let's talk about preprocessor directives. C++ has a small number of operations. Many functions and symbols needed to run C++ are provided in a collection of libraries, and we're going to see in a few minutes what some of those important libraries, at least. Each library has a name and is referred to by a header file, which we place at the beginning of the program. Preprocessor directives are processed by the preprocessor program. Okay, again, in the sequence of program generation and program execution, we have seen the preprocessor program, allows us to prepare the program, before it is converted to an executable. All preprocessor commands begin with the pound sign, right? No semicolon is placed at the end of these commands. So we have libraries, okay, and it is referred by the header file. We have preprocessor directives. The preprocessor commands begin with a pound, and no semicolon is placed at the end of these commands. So let's look at the syntax of that. Here's the syntax of an include, right? Preprocessor. So in here, the include contains the header file name, and IOStream is then the file name for that preprocessor. Now, preprocessor commands are processed before the program goes through the compiler. Like I said, it's a step that is before the compiler kicks into action. Okay, so what is that? Remember the input and output that to C and C out we talk about. In order for that C and C out to work, you need to have this. Okay, you need to have that, and then you need to also use the standard namespace, right? So let's look at that. C and C out, are declared in the IOStream header file. Okay, but within the standard namespace. So you need to do the preprocessor library, and then use the header file, and then also use the namespace. to the standard namespace. Then you'll be able to use CNC out in your programs. And there's some similarly for string, you can do the same thing. You can use the string header file. I'm sorry. All right. So let's go ahead and look at a small program example of how to create a C++, a kind of a skeleton of the C++ program. The skeleton of the C++ program is, of course, I didn't show you the preprocessor header file and stuff, but the actual program itself starts with the main function. And we're going to talk about functions a little bit later on, but for now, just remember that your program will start with the main function. And it will have a bunch of statements, right? And then you have the last statement, return 0. That means we have nothing to return from that. Again, then this in itself is a function, okay? But we're going to talk about that later on. But right now, just know that your C++ program will start with the main, and it will have statements, and all those statements are bundled in a flower brace or flower bracket, whatever you want to call it. Okay, so this is the beginning flower bracket, this is the end flower bracket. All right, so you have a source code. It is comprised of the preprocessor directives and the program statements. All right, we saw that. And they're combined and they're placed into a source code file, right, which contains the source code. The compiler generates the object code or the object file, right, with the extension obj. Then the linker, when the object is linked with the system resources, an executable file is created. It has the extension exe. Okay. As I mentioned before, the first line of the function main is called the heading of the function, right? So this is the heading of the function. Okay. Most of your programs are going to start with the heading. Okay. Moving along. The statements enclosed between the curly braces form the body of the function, right? That's the body of the function. We saw that right here. Okay, this is the body of the function. Right? So the C++ program contains two types of statements, a declaration statement and an executable statement, right? Or it can contain two types of statements, declaration statements and executable statements. Obviously, even the most simplest of the program is going to have those two types of statements in there. So let me show you what I mean by that. So let's look at a sample program. You know, it has the header file, it has a namespace, right? And it has the main function. It starts with the main function, and it has the curly braces that surround your statements. And then you have declaration, right? Declaration. Well, actually assignment. This is an assignment. And then you have a statement that executes and does something for us. And same here also. It provides an output. Okay. So looking back, you know, you have declaration statements and executable statements. So these are declaration statement, assignment statement. This is an executable statement and executable statement. All right. And the return. And it has nothing to return. So now if you notice here, there are a couple of problems, right? When you run this, you're going to get errors. Can you tell me what the errors are going to be? We have line numbers, right, for your program. So you can easily see where the errors are. So if you run this program, you're going to get an error on line 7 and 11. Okay, we're going to get a problem in line 7 and 11. Why is that? Well, I'll tell you. When you run that program, you're going to get errors like this. Okay, when you compile. So it will help you. It will help to have line numbers, right? See, so that your error can show line numbers. So in this case, your error is, it says syntax error semicolon before the identifier num, right? So if you go here on line 7, there's a semicolon missing, right? Before you use the num here. Okay, that's what it's telling us. Here it's telling us that temp num undeclared identifier. Exactly. We did not declare temp num. What is temp num? The computer doesn't know. We declared num, but we did not declare temp num. So that's where the error is happening. All right. So that is syntax error. Those are syntax error problems. All right. And syntax rules indicate something that is legal or illegal. The errors are found during compilation, right? So once you compile, you can get error. So here, you're going to get an error, okay, that you're missing a semicolon and W is undefined, right? So it's not, it doesn't know. Computer doesn't know what the heck you're talking about. So here in C++, you use one or more blank spaces to separate numbers when data is inputted. Blanks are also used to separate reserved words and identifiers from each other and from other symbols. And blanks must never appear within the reserved word or identifier, right? So we learned that, right? So you should not say, you should not type okay, you should not, I'm trying to use the pen here. Okay, so if you have, okay, so if you have, if you have something like first name, right? So if you do that, you have a space in there that you don't want. Let me erase that. Okay, this is terrible. I'm not able to write well. Okay, let's try again. Okay, so if you say first space name, you cannot have that. Okay, string first space name, you can't have that in your identifier. You cannot have space in your identifier. The correct way to do would be to say first and camel case, uppercase N, and name. Okay, that's the correct way to write an identifier. All right. So all statements end with the semicolon. And these braces, curly braces, are not C++ statements. They're not. They're just delimiters. All right. So the commas are also separators. So if you have more than one variable you're working with in a statement, you can separate them with commas. Semantics. Here's an example, a good example of semantic rules. Semantic rules might not have syntax error, but They give you an output or a result that is incorrect. For example, 2 plus 3 plus 5 is not the same as 2 plus 3 in parentheses times 5. 2 plus 3 times 5 and 2 plus 3 in parentheses times 5 is not the same. We know that. Execution-wise, they're correct. Both will execute, right? But one will give you a different result than the other. All right? That's a semantic. That's semantics. All right? So you need to decide, what is it that you want? You want this or you want this, right? Which will give you the correct result, this expression or this expression, all right? Because they are different. They will give you different results. Okay, identifiers can be self-documenting. You can have centimeters per inch. Don't have like this. Don't combine words in a run together. Use camel case or underscore. A lot of old programmers, they use underscores, but the newer programmers, they use camel case because they grew up using camel case in their programming. So prompt lines, you see out for prompt lines, and you can give instructions to the user. Hey, please enter a number between 1 and 10 and press the enter key. Provide the end line so that the cursor goes to the next line and the user can give the number or enter the number. All right. Recommendations on best practices. You need to have your program well documented. Use comments. You learn how to use comments in your programs. Okay. They should be thorough, detailed. Don't worry about it. A little bit of typing will save you a lot of headache and time later on. Again, there are two ways of declaring variables. Method one is right here. You can have variables, define integer, two variables of data type integer, and two variables of data type double. Okay. You can also define in one line, but this is not very user-friendly or readable. I prefer you do this. Okay, practice this. It's clearer, easy to read. Okay, there are two forms of assignments: simple and compound assignments. Right? You can use compound operators to save space. Like for example, simple assignment is x equal to x times y. Okay, so x is multiplied by y and put it into x. That's a simple assignment statement. A compound assignment statement is like this. It uses a compound operator. And these two statements are the same. They do the same thing. Okay, they do the same thing. So x is equal to x times y. This is also x equal to x times y. But we use a compound operator, right, to do the job. All right. So that's all I have for you today in this section of in this lecture of chapter 2, part 2. I'll see you in the next video.